Hi, grade 11s. I hope you're well. I thought I'd just quickly recap on what we know about tangents, even though I did do that last lesson. And then I gave you 3 very easy examples. I could just tell you the answers with the reasons. And then I thought I'd go on to a harder example, the kind of example you're going to get in the exam, where we sort of put it all together. Okay, and I also have to show you the tan chord theorem. Okay, so the first thing I want to show you and remind you, if you are given that you have O as center, all right, and you have a tangent, TAN is a tangent to the circle at A. So that obviously means you have a radius and you have a tangent. Now remember, the relationship is they are always perpendicular to one another. So both of these angles would be 90. If you want to tell me why, you could go A1 hat equals to A2 hat equals to 90 degrees. The reason here, you just put tan perpendicular radius. And that would actually be worth 2 marks, which is quite cool. Right, the second thing I reminded you of in our last lesson, and this is the one where we have a proof. And this is the one I need to show you the proof of as soon as I can, which will be today, this one. So you don't need center, do you see that? But if you are given a tangent, PQR, they have to say in words, is a tangent to the circle at the point of touch Q. Then if you remember, I said, if you look here, we have a chord. Now, do you all agree? I just want to remind you, the chord will break your circle. Do you see that is a segment, and that is a segment. This is slightly smaller than this, so this would be the minor segment and that the major. But as I said, we don't really refer to that. Now remember, if you get an angle, put your finger on the point of touch, and it has to be between the tangent and your chord. Now, do you notice that this angle is sitting there in this lower segment? So if you put your other finger at the end of the chord and you go along the perimeter of this triangle to the circumference, then it will be equal. Now that is what we call tan chord theorem. So if you wanted to tell me why, let's just do it over. You know what? I'll take this away now since we did that one. So if you wanted to tell me that angle T1 hat equals to Q1 hat, which is theta, I know the textbook just goes tan chord. We really want to stress it's tan chord theorem. You can write that on one line, but it's tan chord theorem. Now, before I go on, if I were to put this in words, just listen carefully how it works. So we're saying that the angle between the tangent and the chord is equals to the angle in the alternate segment. Because you see, they're not in the same segments. Now, it's important I tell you that, because I have seen before for 1 mark where they say in words, the angle between the tangent and the chord and then they go dot, 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 and they'll say fill out or complete the sentence. So what you've got to say here, the angle between the tangent, okay, and the chord is equal, and you've got it in words, say, to the angle in the alternate segment. So you've got to know that. But don't write that down, please, as your reason. If you are ever using the tan chord theorem application, you just, as a reason, please just go tan chord theorem. So you can all see that this blue angle here, angle Q3, if you look here, there's your tangent, there's your point of touch. Put your finger on the point of touch with your, they're my glasses, with your other finger, you don't have to highlight it, but put your other finger at the end of that chord so you can clearly see this is the angle between this tangent PQR and the chord, well, whatever that letter is, I think it's T, it's just disappeared, TQ. And you see it's going to go along the perimeter of the triangle to circumference. Do not stop till you get to circumference. And those angles will be equal. All right? So again, you see the angle between the tangent and the chord. Notice the angles in this segment will equals the angle in the alternate segment, but it's got to be at the circumference. The biggest mistake, and you know, it's a big debatable thing, should you show students mistakes or shouldn't you? The debate is, if you show them a mistake, they might do the mistake. But I don't know, I'm more of a positive person, and I think sometimes to see a mistake, you learn from it. So I just want to show you what you mustn't do. So let's say there's another line here, and it just, let's say it randomly comes to a point, just not even the center, just a random point, and it joins up there. One of the biggest errors I see as a maths teacher, people will think that this angle, they go along and then they stop there. And they think, therefore, this angle, if I call it N1, equals Q3. That is wrong, because this is not on the circumference. So do not stop too early. So let's take away that mistake. If they're talking of mistakes, I must read you a quote. It was so adorable. Not today's quote. Could have been on the weekend. Yeah, it was actually yesterday's quote, which was Sunday, the 2nd of August. And it says, in life, we don't make mistakes. We just have happy accidents. And that's by an artist, Bob Ross. Happy accidents. I thought that was quite cute, actually. All right. The third thing I want to remind you is when you are given two tangents, that they have to tell you in the rubric that they are both tangents. They normally would say, for example, TSR and PQR are tangents at the point Q respectively. Now remember, when you're given two tangents from the same point, then you know that those two angles are equal, all right? Because these tangents here will be equal in length, right? Not the whole tangent, just from where it starts outside the circle to the point of touch and to the point of touch. Now, as I said, it's more common that we're looking at angles in this section. So this is where you want to go angle S1 hat equals Q1 hat. And your reason there, you don't have to say two, you can just start with plural of tangents, but I go two tangents, you've got to say same point. So if you just go tangent, same point, that's fine. I don't know why, I'm OCD. All right, so having done that, I want to now go on to this proof. I did show the boys when the boys came to school, but remember, with time, everybody forgets things, and those, my poor girls, you never got an opportunity to come back for a second week, which was quite sad. I'm not even sure when you guys are coming back. I think the government might know, but I'm not too sure. But having said that, we've got to carry on with the syllabus. So after today's lesson, what I might just do is send you photographs of application riders that will be on a higher level, than what you see in your textbook. If you're able to print them out, I would, then do them. If you're not, you're just going to have to do them on your phone or whatever. And then I will send you belatedly the memos, because we've just got to now practice to the right level. All right, let's start off with this proof. So if you were to get this proof, it's going to look like this. They will draw you a circle. All right. Notice this plate is a bit bigger. I've got a watermelon size one. All right, and they will give you a tangent. They're even going to tell you it's a tangent. So they might say PQR is a tangent at point Q. They will tell us that. Then we'll have a chord here. I'll just give it any letter. We'll have a chord over here. I'll just give it any letter. And then I'm going to join that chord. Okay, so they would in the given, now this is a very common exam proof. So take special note of this one. So if they say given PQR is a tangent to the circle at Q, and remember that fancy word, if they wanted to say, they probably wouldn't in this, they could say that points M, Q, and N are concyclic, which means they lie on the circumference. They might just say, given PQR is a tangent to the circle, comma, then name the circle, MQN, comma, then they could say at Q. All right, they're going to ask you to prove. Now, I am not psychic. I try, but I'm not psychic. I can't predict. Are they going to ask you to prove this angle here, so angle NQR, this angle? I can't predict if they're going to ask you to prove it equals to that angle. Or in the exam, would they ask you maybe to prove this angle, angle PQM, equals to angle N. Depending on which one they ask you, the second part of the construction is slightly different. So what I think I'll do, I'll just show you today, here to here, and then I'm going to start making also 5-minute videos. Okay, I've just got to remember to set it for the full 5 minutes and not 4 minutes and 40 seconds, because I always run out of time. And tomorrow, Hasha says she can't do a Zoom, but what I can do is I can put together quite a lot of 5-minute videos. And I could say 5-minute video number 3 on tan chord proof in the other direction. 5-minute video number 4, Pythagoras and trigonometry, etc. I will always name them, but then at least it goes to WhatsApp. And I know WhatsApp, a lot of you find cheaper than the data of these videos, these Zooms. So I'm going to utilize as much technology as this old lady can do. All right, but let's say they say, in this example, prove angle NQR hat. NQR equals, now we would know, because we know how it works, it would equal angle NMQ. NMQ. Now I know a lot of you say, but ma'am, you've just told me they're equals. And I'll say yes, but then you weren't listening to me. Do you remember, we can ask you to prove something. So like last year in grade 10, as I've said, they could have given you a quadrilateral. They could have given you, for example, both pairs of opposite sides equal, and you would have to then prove it's a parallelogram. And if you remember, we had a diagonal construction and we proved the two triangles were congruent, etc., etc. This is a proof. Now, this is actually our last proof, so pay attention. I shall now go into red, all right? So the first thing you need to do is a construction. I have told you every time I've done a proof, if you don't put the construction in the diagram and you don't write it up, you get 0. for the construction, you need to put in your center. All right? You draw a line from the point of touch of your tangent through the center, right the way through to the circumference, and then call that something. Let's call it T for whatever. T. Okay? Just don't call it any of those variables. So if you think about it, you've drawn in a diameter. Please take note you have not bisected any angles. All right? If we were to bisect any angles, we would say such that it bisects whatever. But that's not what the proof, the construction says. It's just going to be join, or actually we're going to mention the word diameter. We're going to say draw diameter, QOT. And if I am proving this angle, okay, is equals to this angle in the alternate segment, then you must join from that point of touch to the direction where you are going, like so. If I was asked to prove this angle equals to that angle, then instead of drawing the line there, I would have drawn it to where I'm going. But I can do that tomorrow in a 5-minute video. Okay, having done that, I've cut this angle up. So I'm going to call that Q1, Q2. I don't need that. I'm going to call that M1, M2. Okay, now what I say, let's just first please write this up and use the word diameter. So say draw and say diameter. I think I'm spelling it right. Q-O-T. And then just say join T-M. That is your construction. Now, as far as now, this is the way I do it.
Oh, Lord.
Differently. Are you still there?
Ma'am, there's someone calling you just now.
Someone's phoning me.
Someone calling you as in they want to ask you something.
Oh, okay. I didn't hear anything. Yeah. Hello.
Okay, ma'am. You answered the question already.
Yeah.
You already answered the question, ma'am.
Have I already answered the question?
Yes.
That's because I'm psychic. So remind me to tell you everything that's going to be in your external exam at the end of the year, okay?
Yes, ma'am.
Just kidding. All right, I'm sorry. If you want to ask me a question, you've got to shout louder because I'm a bit deaf. You know, us old people, we walk around with walking sticks and we have glasses and we don't know technology. So you've just got to... Okay, but anyway, we're proving, let's go back, the angle between the tangent and the chord, we're going to look at chord QN equals to the angle in the alternate segment, which in this example would be NMQ, aka M2. Right, so now I told my students, listen carefully, you don't write what I'm going to show you up now. This is your light bulb moment. Now, you know me and my fluffy clouds, and I know you're all going to say, I can't see green. Okay, fine. That's why I'm going to change to blue. This is my light bulb moment. And I hope you can all see what a fantastic light bulb I have just drawn for you. Now, my light bulb thought, there are two lots of 90 degrees in this diagram. Start off by finding them and give me the reason. And if you do that, you get 4 out of 6, which means you've already got a good mark. Okay, let's see if you can see the 90 degrees. Did I or did I not tell you that a radius comes in at 90 degrees to a tangent and vice versa? So wouldn't your first 90, in fact, I'll keep it in blue so that it ties up with your fluffy cloud. Wouldn't that angle be 90? Yes, it would. Okay, so how would we word that? Because I have referenced it in my diagram, I am allowed to say Q1 hat plus Q2 hat equals to 90 degrees. That would be a mark. Now, you normally write the reason on the right. I just have to write it in a bracket below because of space. But you would write tan perpendicular radius. Wow, that could very well be 2 marks. Unless they decide to make it statement reason and then they're being schnook. But anyways, who could see another 90 degrees in that diagram? Anyone?
Ma'am,
Yes?
wouldn't it be angle M because it is angle in a semicircle?
Who just said that? I'm so proud of you. Give me your name.
Zahra.
Yes. You are high five. Okay? So M1 plus M2. Let's refer to it as M1 plus M2 since we have now kind of, with my construction, sort of split that angle up. You just said, Zahra just said that would be 90 because of angle in semicircle. Remember, a diameter subtends at the circumference 90 degrees. Well done. Let's write that up. Okay? If you want to use a conjunction that everyone knows how to spell, just go also. Then I'm going to go angle M1 hat plus angle M2 hat. That would be 90 degrees. And if you remember, that is just angle in semicircle. Right, now I might be wrong. I might have my other colleagues laughing at me saying that's not worth 4 marks. But I think I am very close to the answer, so I think I am. Now I need to change the color of my pen to this color. Now, is it green, is it purple, or is it something else? Well, that we'll have to see, I don't know. But everyone watch what happens next. This angle Q1, and it is blue. Who would have known that? Okay, this angle here, Q1, I'm going to say to my examiner, let it be X. So watch, you've got to say, let Q1 hat equals to X. Now, let's see if you agree with my logic. If this whole angle OQR, aka Q1 plus Q2 is 90, because tangent perpendicular to radius, then would I be correct to therefore say that Q2 would be 90 minus X? Okay? Because, I don't know if you can see that, 90 minus X plus the X's negate, leaving me the 90. So there's no reason for that, because I've basically said already that the 2 angles add up to 90. So I must just say, therefore, angle Q2 will equals, that's a therefore, by the way, to 90 minus X. Now, this is the bit that you can roll the drums. Dum, 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 dum. Okay, it would be really nice to go into a new color, like purple. Let's see if this is purple. Do you all see this arc? Now, this is a good sign because it's purple. Do you see that arc is subtending angle Q2? Do you all see it? I know these are meant to be straight lines, but I'm so excited because we're so near the end. Do you see the same arc is subtending at circumference M1? Do you all see that? Who remembers what we call those angles? Anyone?
Ma'am, is it angles in same segment?
Is that Zahra again?
Yes, ma'am.
Yes, as you on the ball, my lamb chop. High five. Totally. Do you see there that arc TN? If there had been a straight line, the chord, it's subtending equal angles in the same segment. So this angle would also be 90 minus X. Now watch this. You have to say, therefore, M1, and please reference that, equals who? Q2, and that even rhymes, which equals to, in terms of algebra, 90 minus X. That is angles in same seg, for segment, right? Now that is the 5th mark. I'll make that statement in reason. But I don't know if you can see this, but we've actually done it. Because if this angle is 90 minus x, and the angle M1 and M2 together is 90, then who can tell me how much must M2 equals to?
X.
Is that Zahra again?
Yes, ma'am.
Yes, sis. Another high five. Can you tell the class why this would be X, just for interest? Because?
They're both supposed to add up to 90 degrees. Because
Correct.
they're
So if they
90
both
degrees.
add up to 90 degrees and angle M1 is 90 minus X, then we need a plus X to cancel with that minus X. So we've got enough space to say, therefore, M2 would have to be X. Now, you don't need a reason because I put the reasons here. That is why I said start with the two 90s. Because once you've got your two 90s, you've got your reasons. And guys, they said prove that. So let's just have a look. So angle NQR, let's look who that is. NQR, that's who we called X, equals, let's look at NMQ. Oh my word, that also equals to X. And then you just go equals to X. And guess what? That's your tan chord theorem proof. Wasn't that fun? Zahra, was that fun?
Yes, ma'am.
Who's your maths teacher?
Mr. Matusabila, I think.
Okay, cool. Well, I'm very proud of you and him. Okay? Now, with regards to these kind of problems, as I said, if you go to your textbook, on page 229, they give you very easy examples, guys. I'm just not 100% sure at the back that they give you the reasons, but once you've kind of looked at those examples, the kind of example you're going to get, I'm going to show you what it looks like, but can someone tell me how much time do I have left? Because as you can see, I'm not wearing my watch. I'm charging.
11 minutes, ma'am.
11.
Yep.
Okay. Did you say 11 minutes?
Yes, ma'am.
What a coincidence. Because did you know that you guys are grade 11? That's a good sign. That is a good sign. So we have enough time to show you the kind of example where you will get like in an exam. Sure. Now, I don't know if this is big enough for you to see. I blew it up as big as my printer could possibly blow up a diagram without actually exploding. So I've just got to tell you what they've given. So I'm going to put press-stick there, a little bit of press-stick there, a little bit of press-stick there. Okay, I need to just write here what they gave us because it's very important to read the instructions of what you are given. All right, you might say, man, that picture's not straight. Who cares? Who's to say a circle could ever be straight? I mean, you could put it around and around. It's fine. I'm happy with that diagram. They say basically the first thing in the given, now this is very important. They said DA and DB are tangents. Aha! We have two tangents. We'll look at them now. To the circle. Okay, let's keep going. At A and B, respectively. Respectively. I think that's how we wrote. Okay, now I'm not going on. I'm too excited. I have to stop for a second. I've got to look at this. I really have to look at this. And I always go over my tangents in yellow. I can't explain to you why, but I do. To me, a tangent is yellow. So if I see DA, do you notice I'm going to go over that in yellow? And you can extend it if you want, but I know that is a tangent. The other tangent is DB. Please read the question, not DC, DB. Because as you know anyways, a tangent has to touch a curve at a point. If you want to extend it, feel free. But go over those two. Oh, now watch this. We've got two tangents coming from the same point. So I hope you can all see that that angle will equals to that angle. I hope you can see that. And the reason would be two tangents, same point. But before we go into answering the question, let's see what else they gave me, because there's quite a bit more. They also told me AF equals to FB. Okay, where's that? Okay, so they told me that AF equals to FB. And they do that by two stripes, which we know that's equal in length. Now, lamb choppies, hello lamb choppies, you know that if we have an isosceles triangle, then A2 would equals to B2, and we would say angles opposite equals sides. Please don't say radii because they're not radii. Right, so I just put two little dots there. Let's continue. What else are they giving me? Okay, let's have a look. The line AB is produced to C, all right? And DEC is a straight line, but there's more. Aha, this is important. They're going to tell me that the line FB is parallel to DC. Now, when I get parallel lines, I always like to highlight them. So I'm just going to highlight that line just so I can see it's parallel to that line. Now, the minute you get parallel lines, right? The minute you get parallel lines, you know you're getting special angles. You're either getting corresponding angles, or you're going to get co-interior angles or alternate angles, because DC is parallel to FB. But I don't know which one yet. Let's wait and see. What else did they give me? Okay, they gave me one last piece of information. Angle A1 is X. All right, so angle A1 hat is X. And you'll notice, well, I don't know if you can see, I'll go over that in a bit of a darker black color. If I can find in all my pens a darker black color. Yeah, I found one. They told me this angle here is X. Oh, I'm so excited. Okay, now the first question, and we might not get to all the questions. Yeah?
You have 5 minutes.
Yeah, I knew you were going to say that. We might not get through all these questions today, but the first question said, name 5, I think it was 5, or was it 4? It was 5 angles equals to X. With reasons, please. Now this is a lot of marks. Okay, I can't see how many marks they made it, but let's look. Okay, the first thing I'm going to do, to read this yellow tangent, there is the tangent to this big circle, and you agree that A1, take your finger to the chord, go along the circumference, jackpot. So in other words, B1 equals to who? To A1, which is X. Reason, that is tan hyphen chord, and please write theorem. Now, if you remember my lamb chops, they told me FA equals FB. So I already made 2 dots there. So we know that therefore A2, watch, hat, equals who? B1. Okay, which equals how much? X. Reason, angles opposite equal sides. Now, look at this. If we have two tangents from the same point, as I say, we know that angle A1 plus A2 would equals to angle B1 plus B2 because of the two tangents, or just tangents, same point, right? Now, what's the point of that? I'll tell you the point. Collectively, this angle is 2x. Look, x plus x. And B1 is x. So if these angles are equal, then B2 has to be x. So therefore, you will just say B2 would have to be x. And literally, it's the same reason. Okay, it's the same concept. Now let's look at these parallel lines. I know, oh, look. D1 is x. Do you see the alternate angles? I knew that was going to happen. All right, so D1 hat equals to who? B2. That rhymes, which is x. And remember, if you go alternate angles, if you do not acknowledge the DC parallel to FB, you've just lost that. Now, let's see if we can find more. Okay, I'm looking very carefully. And you know what I am seeing? I am seeing what am I seeing? I've got 1, 2, 3, 4. We've just got the one more to do, lab jobs. We can do this. We can do this. Okay? Let's look for, very often when I can't see something, it's very often corresponding angles. Let me see if I'm right. And let's just quickly, just look carefully. I have here a line. I have a paraline there and a paraline there. So that makes an F, right? Oh my word. Did I not say if you get stuck, it's normally the corresponding? Do you see how clever that was? So you want to say that angle C hat equals to B1 hat, which is X, and that is corresponding angles because DC parallel to FB. Now, there are more questions. We're not going to get there, but let's look at the mark allocation. The first one, statement, reason, 2 marks. Second one, statement, reason. This one, 2 marks. This one, statement, reason. This one, statement, reason. How many marks is that? 1, 2, 3, 4, 5, 6, 7. Okay, now 7 marks is pretty cool. Okay,